All right. So going to the first question, it says whether the overall density of the balloon and instruments greater than, less than, or the same density of surrounding air. If the balloon is still rising, then of course the density has to be with the density of air inside. Oh, it says stationary in still air. Oh, it's not rising. So it means that it has the same density. Now, let me tell you, if the density inside is greater, it would actually sink. If the density inside is smaller, then it would rise. And if it's equal, then it will be stiff. Now, state whether the balloon rises, falls, or remains steady. At night, the gas in the balloon cools. So the pressure of the air outside remains the same. So if it cools, then it will fall because density will be higher. I explain because volume decreases and density increases. All right, please let me know if you have a question here. Then it says object axis speed versus time. So it says that the balloon rests, it starts from rest, eventually reaches a constant speed. So it will, because of the air resistance, it will be like this, okay? State the values of initial acceleration, that should be 10, right? Meters per second squared and downwards. And final acceleration should be 0 because it will reach constant speed.
Sir, where did you get the 10 from?
That's the acceleration due to gravity. Yeah.
Okay, sir.
So initially, if there is air, right? So always there is G is 10, and then as it goes up, it reduces. Okay. Now, then define the moment of a force. So moment of a force is the force, and you can write multiply by the perpendicular distance. Writing perpendicular distance is very important. Okay. Now, from pivot. Now it says an object is free to rotate about P. Where is P? Okay, that's the pivot. Calculate the force. Calculate the value of force F. So if you look at it, its mass, its weight is going to be 50 times 10. So that's 500 newtons. So basically, this rope is being pulled by 500 newtons, and the force is here. So the perpendicular distance, this will cause it to go anti-clockwise. This will cause it to go clockwise. So 500 times 20 equals to, so I'm doing clockwise equals to anti, okay. And this would be F times 12. So 500. That basically comes out to be 830 newtons. Okay. Describe an experiment involving vertical forces. Show that there is no net movement on an object in equilibrium. You may draw a diagram for this. Okay. So there is a couple of things you can do, right? So if I were you, I would draw it like this. I would draw a plank. I would put a pivot. Okay. On the plank, I would then attach a Newton meter. Right. And then I will actually add a ruler, or take this as ruler, it doesn't really matter. And then you can add masses, or you can call them slotted masses. Now, basically, you can move the mass like forward and backwards, and then you can check how the reading changes, and then you can apply the principal moments in each direction to confirm whether it's in equilibrium or not, right? So to write this, I would say that move slotted masses and check the new reading on Newton meter, right? Apply principle of moments about the pivot to confirm whether it's in equilibrium or not. Is it clear, everybody? Please let me know if you do not understand this.
Can you explain this again?
Like you see, Khadija, Newton meter gives you the force, right? Mhm. So if
Yes.
you add more mass, right, would the force change here?
Yes.
Alternatively, you can actually move the mass from this side or this side. You will see that the force will change because the moment is changing, right? Sometimes it needs to provide more force or less force. So every time you do an increment, you get a new set of force here. So what you do, you have this distance, right? You have the new distance that you moved and the mass of this. You can find the force and then you can apply principle of moments. What is that? Clockwise equals to anti-clockwise to prove that it is an equilibrium. Understood? So because there are like two forces of so there's because there are two conditional equilibrium. One that sum of all forces is 0 and sum of all moments should be 0. All right. Anybody who still doesn't understand, please. If you have like there are other methods as well, right? But this is the best one. All right.
Right.
So the next one.
Can
Yes,
we
Sadia.
write that sum of anti-clockwise direction is equal to sum of anti-clockwise direction?
I have written apply principal moments. If you want to write apply sum of clockwise moments equals to sum of anti-clockwise, that is the same thing. Don't you think so?
Yeah. Or is
So
it, can I write that sum of upward force is equal to sum of downward force?
yes, you can also write that, but then the thing is that you say that I will keep both the distances from the pivot equal. Do you understand?
Yeah.
So when you add masses, this force and this force should be same. You could
Okay.
say that. Do you understand? Like that. So it's up to you what kind of experiment you want to create, whether from principal moments or sum of forces. That's up to you. Now, the water falls 15 onto rocks below. Show that the velocity of this is this. Okay. So gravitational potential energy goes to kinetic, right? This cancels out. 10, height is 15, half times p square. So we will be, message message type. So this will be 300, I guess, right?
Square.
I don't know.
300 square.
300 square cube, 300 times 2. That would be 300 under root. 300 under root would be the answer, right? And the answer is, what is 300 under root?
17.3.
17.3. Okay. Oh, we got it. That's great. Now 30 kg water flows over the cliff, cliff edge every second. Calculate the force exerted by rocks on the falling water. So you have the mass. You have the mass. You have the velocity. What can we do about it? Okay. So force is equals to ma, right? We could use that. So if the speed was here, so we could say force, we need to find mass is 30 kg, acceleration is, final velocity is 0, initial velocity is 17.3 over 1 second. Can you do this? 30 times 17.3. This is the force on the rocks. We need to find force on the water. So it will just be not minus. So what is the answer? 1370, 520 newtons. Is it clear, everybody?
Yes, sir.
Yes, sir.
ये आपने अच्छी तरह चेक करना है किसने भेज दी थी या नहीं भेजी थी, ठीक है। भेजिए, ये भेजी तो इसने 4 मार्च को, तो मार्च को 4 मार्च को भेजी है। अच्छा, ठीक है।
Sir,
Yes.
the value you get is a negative, but you can ignore that, right? You can just write factority.
Negative is the sign that this is the force acting on the rocks. He said rocks. So that's the force of rocks on water will be opposite because of Newton's third law. So you can just ignore it. Okay.
Okay.
Then pollen particles are mixed into
Okay.
liquid. They're been observed through yes.
So if we write minus 519, then it will be wrong.
It will be wrong, Adya, because they say force exerted by rocks. So you have to show the opposite force. Okay.
Okay.
Now, pollen particles are mixed into a liquid. They seem to move when observed through a microscope. Describe this movement. It is random, always. Explain this movement in terms of molecules of liquid and the pollen particles. So what they do? Water molecules.
So you can also write that's a sliding motion, right?
Fast. Sorry?
For part 1, you can also write that it's a sliding motion.
Yeah, you can write that. You slide like sliding between layers? That's what you're saying?
Yes, because it's liquid.
It's talking about pollen particles which actually float. They have no mass actually. They're very less mass. Okay.
Okay.
So you have to write that it's random because they're hitting the molecules, right? Because move fast, water molecules move fast, they collide with pollen particles. So the molecules move randomly. All right. Now, medical professionals sometimes rub ethanol over the skin of patient. Ethanol evaporates readily at room temperature and high specific latent heat of vaporization. State whether the patient experiences heating, cooling, or neither at the site where the ethanol is applied. Explain your answer. Now, of course, when the evaporation happens, it has to go through cooling, right? So the cooling basically is that you can actually, this is actually regarding the evaporation. So you say energy is used to overcome attractive forces. The thermal energy is taken from skin of patient, right? So most energetic molecules escape. So state any effect or rate of evaporation ethanol when fan blows. Of course, it will be greater because I told you if there's increased wind, that would be greater. Okay. Okay. Now, a machine delivers a hot drink in plastic cup which is uncomfortably hot. Okay. Then it says explain how using the holder makes it more comfortable to hold the cup. Okay. All right. So that is because if you look at it, air which is trapped inside, right? Air is a poor conductor. Then 1 mark. Second mark, you would write that so holder would reduce conduction, right? So third thing is that the temperature of outside the holder is lower. Hello. Walaikum Assalam. जी जी आवाज है अच्छा
Sir,
all right, yes, what you say?
so wouldn't you say that the hot air from the drink is entrapped between the two paper cylinders with the air gaps in them? Or is that like not what the question is asking?
That's what the question is asking. If you look at the holder, right, it has air gaps between them, you see? So when you hold it, it means that air is a poor conductor, so it doesn't, conduct the heat from the glass to your hand, and it is comfortable because your hand is lower temperature outside.
So if
Is
I
it-
write the whole entrapped thing, then that wouldn't be the right answer, right?
Air trapped. I don't understand what you said last. Fine.
I think I give a reason instead of what it is, because I wrote that the hot air from the drink is entrapped between the two paper cylinders with the air gaps in between. Therefore, the hot air does not reach the person's hand.
Yeah, that's correct. That's correct.
Okay.
You could write that. You could write that. That's fine. Okay. The student carries out an experiment on cooling of the hot drink described without holder in place. He finds that the holder only reduces the rate of cooling slightly. Suggest and explain another action that reduces the rate of cooling more effectively. So what you could do is you could actually put a cover on top. What cover does is that basically it reduces convection. It reduces convection as no heated air escape, right? And then what you do? Second point could be that it also reduces evaporation. So evaporation causes cooling, right? So if it reduces evaporation, it won't be cooled that fast.
So what if you just write it reduces evaporation?
You just write evaporation.
Yes.
You could do that, but I think that, yeah, well, if you do that, it's fine. I think it's fine.
Okay.
So you can write this, that's fine. State a method of thermal energy transfer from a star through vacuum radiation. Only radiation can go through vacuum. Then shows a ray of green light and a blue light is directed towards the prism's same path. Draw the path. So blue is will actually be more like it will be like this. It will actually refract more. The reason is that blue has a higher frequency, by the way, right? And the refraction should start from this point. All right, so it should be within the glass and after the glass as well. So the both of them should be visible. All right, then it says frequency V is equal to F lambda. So the speed of light is this, no matter which light it is. इसको निकाल लें. Let's see. -7, right? So this would be, I think, 6.3 times 10 raised to power 14 and hertz. Please write this. If you have any questions, please let me know, right? So we did this, and then we are going to 7. Shows two magnets and gaps in air. Draw 3 lines to show the pattern. So north to south, then a curvature. So at least 3 lines. Okay. Then says repeat and showing 2 magnets. Draw the position of plotting compass needle when it comes to rest at the gap between north and south pole. So the position of plotting compass, right? It should come to the rest. Why? So if you put a plotting compass, right? So compass would always show the direction this way. So it should show the direction of the field, right? So that's how. Now, explain why the needle comes to rest in this position. Because you need to understand that the needle of compass must always show direction of south. South. So the field, so it aligns with the field between north to south, like this. So because it's a straight line here, if you put a compass, it will be like this, right? Now, ठीक है, सही है, बस वो देखें वीडियोस जो की हैं आज वो अपलोड करते हैं. Describe कल की भी वो जो थी ना और आज की. Describe a method demagnetizing a bar magnet. So there are so many things you can do, right? If I were you, I would say that place a magnet in a solenoid with AC voltage. So that's one mark. And the other mark is slowly pull it out. That would cause, deactivation. The demagnetizing. Okay. Then you have this, fine. It says there's a plate of this, and there's vacuum, fine, and there is alpha particle and mu alpha and gamma. So first of all, it says write a symbol A once in a table to indicate any deflection of alpha particle. Alpha particle is positive, if you know. So alpha particle will be deflected like this towards the negative. So alpha will deflect towards the bottom of the page, so alpha, and gamma will show no deflection because it doesn't deflect at all. Now, it says draw the poles of very strong magnet to each side. Okay. Type. Okay, so gamma will not be deflected. It's not deflected. However, if this is the field direction, which is north to south, so you have to use left hand Fleming's rule. So your index finger like this, your middle finger will be like this. So your thumb will be pointing inside or towards the screen. You can check. So it is into the page. So that's how it is. Right. So so your index finger should be like this. Okay. This is your index finger. And your middle should be like this, index, middle. So you will notice that your thumb is pointing towards the screen that you're looking at. And this should be left hand Fleming. Can you check?
So which rays are these for? Which rays is for gamma?
For alpha.
Oh, I thought alpha was towards the bottom of the page.
No, it is. It was bottom in the previous example where the negative plate attracted it. In this one, you have to use Fleming's rule to check.
Oh, okay, I get it.
Okay, so it should be into the page. You can check it. If you still have any doubts, okay, about Fleming's rule, let me know. Let's clear it up.
Yes, sir, I don't understand this one about how it is into the page.
So you know Fleming's rule.
Yes, sir.
Can you point your index finger towards south?
Yes, sir.
And then turn your middle finger without turning this, or turn your wrist so that your middle finger is in this direction of current.
Yes, sir.
Where is your thumb?
Above.
It means you don't know Fleming's rule. Your thumb should be pointing towards the screen that you're looking at. So if you remember,
Okay, sir. Yes, I got it.
or just, for others, I just want to show you. So you guys can remember this. Wait a second. So this is, your hand should actually look like, where is it? This. So you have to adjust your hand this and then put your fingers according to whatever the direction is. All right. Try this. If you still don't get it,
Okay.
please. Now, yes.
Gamma would never deflect.
No, because it is not charged. Only charged particles or rays deflect. Okay.
Okay.
Now, state and explain the direction of rotation of coil as is seen. So if you know this, the current will go here, and then it will go here, and then it will go here. Now again, the Fleming's rule. Index finger here. Your middle should be pointing this way. So the thumb should be, can somebody tell me? So I'll know that you guys know. Where is your thumb then? Left hand, please. Thumb is on top, here. And then in this one, index, your middle finger should be like this, and now thumb is down. So this means that it is going to rotate it clockwise. So we are going to write that it is clockwise. An explanation is that force on left wire is up and right is down. All right. Now, coil rotates to 90 degrees position. What happens to the movement of the position? When the coil rotates to 90, so basically every time it does, then you should understand that there will be no movement. Why? Because current will be zero. Because it goes here, right? So it's the commutator disconnects the current. That's fine. The coil is rotated to 180 position, considering the force of coil. Explain how the split ring commutator enables a turn continuously. I wrote it for you too, that split ring commutator causes the current to reverse or change direction so that the forces stay at the same direction. All right. Any questions, please let me know. All right. Give me a second. All right, now going to the next one. It says shows a circuit, two clearly labeled diagrams, direction, convection, current. The current in motor is 13 amperes. The charge on electron is this. Calculate the number of electrons that pass through the motor every second. So current is charge upon time. Charge would be 13 amperes times 1 second.
Sir, you
So
pick the
this-
part A.
I forgot. Shows. Okay, draw two clearly labeled arrows for the direction of electron flow. So electron flow should be like this. This is electron flow. And this is convection current. All right. So then you find the charge. And now what you do, if one electron has 1.6 times 10 raised to minus 19 coulombs, then how many electrons will have 13 coulombs? So you cross multiply, right? So the N is going to be 13 divided by 1.6 times 10 raised to minus 19. So this comes out to be 8.1 times 10 raised to power 90 electrons. Okay, is it clear, everybody? Now, then what you do in 10, it says potential, calculate the resistance of component K. Calculate the resistance of component K when the current is 4 milliamps. So I would want to find, like, go here and then check what is the voltage here. The voltage is 8.4, 8.8, and 9.2. So volt R equals to V upon I, 9.2 volt divided by 4.0 times 10 raised to minus 3. Why minus 3? Because it is in milli. I need to change it. Okay. So when you do this, it should be 2300. And the unit is ohms. You can also write ohms if you want to, but making omega is better. Then shows a circuit. At low temperature, the component K has much greater resistance. At high temperature, lower resistance. Fine. State and explain the effect of lamp when the resistance changes to low to high. First of all, refer to voltage of X at your point, right? So you should always remember that when the resistance of K is high, so resistor R will get less voltage, right? And then when it is greater, it will get much higher voltage. So state and explain the effect on lamp when the temperature goes from very low to very high. If it goes from very low to very high, this means that the lamp will glow brighter. That's for sure. And explanation for this is that resistance of component, which is basically thermistor by the way, component K reduces, hence voltage across it also reduces, right? So the bulb gets more voltage, hence glows brighter. Yes. Any questions? Now it says state the name, that is thermistor. If you have any questions, anything you'd like to understand, please let me know. All right. While you're checking this, please mark yourself, all right, okay? So that you know that where are you standing right now and where will you be standing once we are quite ahead. Now you have this question, says the background is 20 counts per minute, determine the half-life. So what you do? First, if you look at this value, this is 210, 220. So 220 minus 20 is 200. So this is here. So 200 half is exactly like 100, right? So one half-life would be be right here. So 200 to half, and then you do this. I think that no, 200 plus 20. So it's all right if you take this as well. It doesn't matter. I took 120 because at half of 220, at 200, half is 100, but background reading will be here, right? So exactly here, you will get 2.2, 2.4. So that is 2.4 minutes. Everybody understand this? Why I took 120? Because 200 half would give us the half life, and then the real detector will be showing this at 220. So I've checked the time at 120. Sorry. Calculate the count rate detected at time 9.6 minutes. So 9.6 minutes means, oh, what? He has not given this. This is not fair. All right. So at 9.6, we can actually check. So 9.6 divided by 2.4. What is that? Can anybody tell me?
Four.
Guys, 4. That means it means there are 4 half-lives will be passed, right? So let's do 200 times half will be 100, then half will be 50, then half it will be 25, then half it will be 12.5, right? Now the count rate will be 12.5, which is approximately 13, plus background reading is 20. So 13 plus 20 is 33 counts per minute. Is it clear? Background is always
Sir,
the
I
same.
don't understand the both questions, the first and second one.
You did not understand this
Both.
and this.
Yes.
Okay. So he wants us to find the half-life, right? And there is a background radiation this much, right? So currently, what is the detector showing you? 220, right?
Yes.
So actual reading is 200, right? So the half-life will appear when 200 will become half, that is 100, right? At this point. Is it clear? But the detector will be showing you what? Yes, Zahan. Detector will be showing you 120. Is it clear?
Sir, yes, yes, sir.
Because it will still add background. So you go at 120, check what is the time. That was 2.4 minutes. Okay. Done.
Yes.
Now it says what will be the count rate at this much minutes. So whatever, this is a time of half-life. So how many half-lives will be in this minutes? I'm going to divide this. So there will be 4 half-lives. 4 half-lives means I have to multiply 200 with half 4 times. Okay. So
Okay, sir.
200 times half is 100, then half again 50, then half again 25, then half again 12.5, right? Which is like 12. You can take 12 or 13, depends whatever
Yes.
you want to. What to do then? Let's take you around it to 13. So the real value is 13, and the detector will be showing you this plus background. So 13 plus background is 33. Is it clear? It says what is detected. Do you understand this?
Yes, sir.
All right. The substance emits alpha particles and gamma rays. The student suggests that it is safe to store the substance in a plastic container of thickness 2 mm. State and explain whether the student's suggestion is correct. It says substance emits alpha and gamma rays. The student says that it stores safe substance plastic container. That is wrong. You know why? Who's going to tell me what's the right answer?
It
This
should
is
be in lead
because, yes, because
Gamma
plastic
can pass through plastic.
Yeah, does not reduce gamma. So what you want to do? Use lead container instead. Is it clear?
Yes.
Good. Now you guys have any questions? Paper is finished.
Sir, does the lead container completely stops it or reduces it?
It will reduce it to safe level. Never
Okay.
ever completely stops it. Okay. All right. So I guess I'm gonna see you then. Bye.
Love, sir.
Sir,
Yes.
I have a question from sound chapter.
Yes.